Hey guys, Grapple is back. So today we're going to do the part 2 of the Grapple tutorial. We'll use these yellow ones, so you can do this like a real pro. Also multiple times, like the true Ratchet and Clank game. So this is kind of a long tutorial. Yeah, kind of. So let's start. In order for this to occur, let me give you some insight on what's actually happening. We actually do many stuff. You see this ball? Yeah, this ball is actually doing the oscillation, is actually doing the actual grappling location changing like that. But we're using a constraint to do that, and this is this part right here. It just takes two stuff, links them together with kind of a unbreakable and unbendable rope. So this is a Grapple, a physics constraint actor. I named it Grapple constraint. Then I pass its reference through our level blueprint to our third-person character. I create a new variable called Grapple constraint right there. I pass this around on event begin play. This by default is not attached to anything, and it's like the default everything. I did not change everything. I just drag and dropped it into the level. So going back where we left off on our third-person character, we left off right here on our yellow Grapple point. We set the yellow Grapple. What we actually do, because the third-person character is not a physics body, that means it cannot be pushed by a ball or something. It cannot be tied to physics events and stuff. We need to spawn another object with the same mass as our character, so it's like essentially the same thing, the same properties. Make you do the whole grappling orbit. Move the player along with that object without them being attached, because when you attach something to a physics object in runtime, weird things happen. They need to be pre-attached for that. Also special thanks to Board Engineer for mentioning that and helping me a bit with this tutorial. Then, as I said, we spawn this physics assist object, which is actually a sphere with just a physics body collision type with ignore on most as well as spawns. We set the mass simulate physics zone, also gravity zone. Now we spawn that in our actor's location. We grab a reference, which is the grapple helper variable right here. We hit an event that's called mass update on spawn. This is actually just grabbing the mass from our character and setting it as the sphere's mass, so the forces are equal, yada yada yada. So yeah, pretty basic. Then we set its velocity to our player's current velocity, so it's like uninterrupted. We don't just spawn something with zero velocity. It's supposed to be our character as a physics body. So we pass it, we pass our velocity around, and then we constrain the components. We set the first component of our Grapple constraint, which is this part here, to remind you. And the first target is our root sphere, which is essentially this yellow thingy. This is supposed to be simulating physics, but locked position in all axes and locked rotation in all axes. So we don't want this to move at all. It's like standing there. It's like a wall. Before we do that, we set the Grapple constraints location to our hook target, which is the small arrow right there. So we want our top part to be placed here. If this doesn't happen, all sorts of crazy things can happen, because it's like we've got two movable objects. One here, the constraint is where my cursor is right now, and the other part is on the character. And we don't want this to happen, because the oscillation should happen on around this axis. the Z or the X or the Y, this origin. So yeah, that's basically it for our for the grapple initialization mechanic right there. I also added an event that's called grapple start, but yeah, who cares. Now on our reset part, grapple end, if the state is yellow grapple, which is what I'm explaining right now, we set the state to no grapple. We get the physics linear velocity from the assist object and we pass it around to the player because we don't want nothing to be wrong. We just pass the player just because the way we're using to move the character is not actually by adding a force but by interpolating, which I will talk about later. We pass back the velocity, then we clear the constraint components, so we reset our physics constraint object, and then we destroy our helper because we don't want an invisible ball doing a random oscillation anymore. Now, about the actual moving on the tick event, if we're doing the yellow grapple, we're just grabbing our grapple helper object, which is this sphere that's oscillating, and then we set our actor location to that. We also do a sweep, so we don't want to like go through a wall or something while the sphere travels. So another part I'd want to talk about is what I'm doing here with the move forward and move right controls, but that's a whole other story. Because we're interpolating, if we don't do this speed thingy, which we jump when the grapple starts, we actually pass our speed to the invisible ball that spawns. We interpolate no, we actually set our character location to the ball's orbit, so it moves along. And then in the end, we want to grab the ball's physical linear velocity, and pass it back to the character, so he doesn't like move forward or do crazy stuff or just stand still in the air. Now, we also want some control over this because, yeah, this may happen sometimes. And the player can go like this and he will just die if he falls down to lava or something. We want the player to be able to change how he moves, so I can do circles right there. As you can see, I'm moving the WASD keys now, and then I can just lift off and go on the next jumping pad. Now, how do we do that? We actually remap our move forward and right events to two extra stuff. So a sequence, the first standard add movement input in both. Then on the second pin, we check if we're grappling, and especially if we're grappling on a yellow grapple point. So what do we do essentially? We add the force, but not on the character this time, because the physics are not affected by our character, if you remember in the start of the video. So we just do essentially this thing, but on the sphere. And this 50,000 is a constant, just to provide enough thrust for our character to move, because he's heavy, he's got mass. Basically what we're doing is grabbing our forward vector. If we're going forward, it will be multiplied by 1. If we're going backwards, it will be multiplied by -1. And this applies to analog input as well, so it will be scaled accordingly. And then we just add some extra magnitude to the vector. And the same thing with our right vector right here. If you want to turn right, it will be multiplied by 1. If you want to go left, it will be multiplied by -1. And then the same extra velocity. This, you have to play around with these values because they're the constants that define how your game behaves. So, and remember, we add this to our grapple helper's sphere, which is this sphere. If we do that, the player can then do a loop. Actually, if we don't moderate that, he can go the whole circle. He can do a loop, he can mess around with stuff, and we don't want that. He can launch it himself into the sky if he wants to. So then a special tricks comes in, which is clamping. If you see right there, we cannot like, if we do set max, we only get a max angular velocity, but we want to set an actual max linear velocity, because our character has not got angular velocity, he has only got linear velocity when we disengage from the grapple right there, we pass the velocity back to him. So what we do essentially is a custom version of a set physics max velocity, just because it's not implemented in the engine. In future versions it may be implemented, but who knows, till then we'll have to use this trick. We get the velocity and we set the velocity. But between these steps, we do this thing. We break a vector and we make a vector. We grab each parameter of the vector, x, y, and in the x, y, and z axis respectively, and we clamp them to the same minimum and maximum values. Minus 800 and 800 work for me perfectly, because I did a debug test to see how high the speeds are when we go and make a loop, and it was around a little bigger than that, almost 1,000. So I'd say, yeah, just remove the 100, check if it's working. It's working great. I did a lot of tests, it's great. So yeah, there you go, that's the grappling tutorial. I know it's long, it's kind of confusing, you have to understand how constraint works, some tricks like this velocity pass through that happens just to get the mechanics straight and don't fuck around stuff. Actually, there you go. And you can also do them in succession. So like one here, the second one, and the green one. There you go. You just crossed a huge gap like in Ratchet and Clank. See you in the next tutorial.